go ahead and get this started. Saturday classes, real quick, before I get too deep into the lesson. Brandon and I keep running across, writer's block, so to speak. We want to come up with some classes that you guys need or want, and we need your input. Send us a message, please, if you can. Hey, I really want to learn how to do this. I really need to know how to do this, because we sit down and we say, okay, we got class this Saturday. What are we going to do? I don't know. What do you want to do? Well, what do the guys want? And, we're trying to figure out a class that would reach a majority of the audience. We don't get a lot of people coming, and we know that if we're going to talk about dryers, maybe people are very comfortable with dryers and they don't really want to come to the class. So we have to find stuff that you guys need. So without your input, we don't know what to do. So we are making up all kinds of material and trying to put stuff together. Plus we're creating all this behind the scenes online classes that you guys can go through. Hopefully after the Christmas break, I'll have dryers and washers also released. And this is more, what is a washing machine? How do the cycles work? What are the components? What do the components do? So these online classes are not classes like, here's a schematic, troubleshoot a schematic. It's more along the lines teaching you what the appliance is. And that is also leading up to what I wanted to talk about today. We talk about troubleshooting a lot. Every job you do, you're troubleshooting a service call. But your problems are always different. And I want to just go over, what tools do you need? What thought process do you have to have in order to troubleshoot? What type of problems do we look for? What are the steps that we should follow when we actually troubleshoot? When does troubleshooting begin? What is it? And that's what today's class was going to be. I am going to go a little bit over schematics and a little bit of diagrams and testing on the diagrams, but I also wanted to get into, when you guys come into a job, I remember when I first started working in appliances, I learned appliance repair, and I walk up to, take the card.
Where is it?
I don't know. Oh, in the bedroom. I'm sorry, guys. So when you're troubleshooting, and I walk up to a machine and the machine's not working, the first question that always goes through your head, especially if you're sort of new into this industry, is, okay, where do I begin? What do I do first? What do I do? I know it's not running, or I know it's not heating if it's a dryer or everything, but when I approach a machine, the biggest question I have is, okay, what do I look for? What do I test first? All these things are important when you're troubleshooting. And I got some questions here for you guys. I want to have a little more interaction with these classes. What knowledge do you guys need, just general, what knowledge do you need in order to troubleshoot an appliance? General.
Electrical.
Okay, so you need to have an electrical understanding, right? Like, you have to know what electricity is. Hold on a second, I'm talking and typing at the same time, it don't work. You have to have electrical understanding. You have to know what electricity is. You have to know schematics. You have to know the electrical components. So components, schematics.
Meter, how to use a meter.
Okay, meters. What type of meters? You're going to troubleshoot any appliance except for, let's say, refrigeration and seal system. Let's leave that out because that's a whole nother can of worms. But you're going to do a machine and it has an electrical problem. First of all, there's 4 main meters you have that you can use to do some sort of electrical testing. What is that going to be? A voltmeter? Voltmeter.
Ohms.
Ohms.
Amps.
Amps.
Clamp on.
Okay, amps. One more.
Resistance.
No, ohms is resistance. Oh, I typed ohms wrong. Look at that. Watts. You can have a meter that does voltage, ohms, amperage, wattage test, but which one do we use when? I mean, have you guys, let me ask you a question. You're working on a dryer. How many of you pulled out a watt meter to test a dryer? How many of you even have a watt meter? Most of you don't carry watt meters. Probably never ever used one. That is not one thing that's going to troubleshoot for you. What is wattage? What is the actual wattage? If I was checking wattage, what am I checking?
Checking power.
You're checking power. A light bulb is 50 watts, 100 watts. That's how bright the bulb is. If I'm measuring wattage, I'm measuring how much power is coming out of it. I mean, if the light bulb's on, I don't care if it's 60 or 75 watts printed on the bulb and it's putting out 60 watts. You're never going to measure that. Okay? The same thing with amperage. The only time you guys probably ever hear to test amperage is check amperage on a compressor, see if the refrigerator's cooling. When have you ever heard amperage on any other appliance? Because if a part's not working in the appliance, a motor, a heating element, light bulb, or whatever, there is no amperage. And if the heating element or motor or light bulb's working, there is amperage. So amperage is not going to be a test you're going to make to say, oh, the dryer's not running, let me do an amp test. Because it's not going to have amps if it's not running. The two tests or meters you want to use are your voltmeters and your ohm meters, or ohm meters. Let's see. Sorry, I can't type and think at the same time. So those are the meters you're going to do. But are all your appliances going to be electrical problems? Okay, and again, we're excluding, for those of you who just came in a little bit late, we're excluding sealed system problems, okay? So we're dealing with washer, dryer, dishwasher, stove, whatever. But we started off with what knowledge do you need? Okay, so we have to have an electrical understanding. We need to know what meter to use and when. Voltmeter and ohm meter are the ones you're going to always use. But what else do you need to know knowledge-wise?
Basic function of the equipment.
Okay, so let's just say dryer to start off with. So you have to know a dryer. Okay, so you have to know basic function. And the basic function would also be its cycles. You could have a gas dryer, you could have electric dryer, you can even have those heat pump dryers, which has like a sealed system and it has a compressor, condenser, and evaporator, and they use the heat off the condenser to dry the clothes, and the evaporator to take the moisture out of the air. But you need to know basic function. Well, is it a gas? Is it electric? Is it a sealed system type system in that dryer? And now if you know the function, don't you need to know the actual components within a dryer? I mean, you have to know the function of the dryer. The dryer dries clothes. It has components. What does a dryer do physically? When you press start, what is the machine doing to dry the clothes?
Heating and heating.
It's what?
Tumbling, spinning, and heating.
Okay, so the drum's turning. It's heating. And we need one more thing. The back of the dryer.
Exhausting
airflow.
hot air or air.
Airflow. Okay, so you got drum turning, heating, and airflow. Those are the three major problems you're going to have. Yes, you'll have some other ones where the board don't light up or whatever, but we're talking in general troubleshooting, okay? So you want to see if the drum's turning. The motor could be running, but the drum's not turning. The motor may not be running and the drum's not turning. Heating. In order to know heating, you need to know a few things. Airflow. Let's just talk about them for a second. Drums turning. What do you guys know about the drum turning in a dryer? It goes around, right? You don't know what I'm asking you, but I had a dryer, a Frigidaire dryer. Unit was only a month old. It was a laundry center, washer in the bottom, dryer in the top. Wasn't drying the clothes. What's the first test you make?
Voltage.
Okay, well, it's running.
Is it 240 or 120?
It's 240. Chad, if you're talking, it's a little bit hard to hear. You're too far away from your mic. So it's 240. Dryer's running. First thing I want to do is drums turning. Is it heating? And do I have airflow? Right? Scott, I see you said check power, but I'm saying it's running, but the customer's complaining her clothes aren't drying. Okay? So I turn it on, I see the drums turning, I'm checking to say, okay, is it heating? So the lady has it in a laundry room in the back of her house, and the dryer shoots straight out the wall. There is no vent going up to the roof. The dryer's not in like a closet where the hose behind it is crushed. But I take the dryer and I pull it out and I put my hand there and I see it's heating. Okay? Well, so it's running, there's airflow, and it's heating. There's more information. What temperature am I looking for? I know it's heating, but is it getting hot enough? So what is the temperature I'm looking for? This is the information. When I break this down, I say, what knowledge do you need? Yeah, you need to know the dryer's running. You need to know it's heating. You need to know airflow. We need to know temperature. Because if it isn't running at the right temperature, it's not going to dry. It may dry after 2 or 3 loads, but a lot of you will say, oh, if it takes 3 loads to do it, it's your vent in the house. Get your vent clean. It's crushed behind the machine. It may not be. It may be a heating problem. Okay? So you need to know temperatures. And if you guys don't know the temperatures, I'm going to give you 3 heats. Low heat, medium heat, and high heat. High heat is your towels and sheets and stuff. What temperature should we be at in high heat? I saw what you said, Douglas, but I didn't hear you. So it's about 140 to 160. Okay, I read your lips, so I know what you said. So it's 140 to 160. What about medium?
Is that 120 to 140?
No, it's about 130 to 140. Okay, that 130 could also be in the low temperature range. Okay, so high is about 140, 160. Low is about 130 to 140, and then medium somewhere between 140 and 150. It varies on the manufacturers. Okay. But if I got a customer telling me my dryer is running and not heating, first thing I'll do is I didn't say not heating, I'm sorry, not drying. I want to pull it out and I want to see the air's flowing. I want to see the temperature coming out of the back of the dryer. So let's continue with this problem now. So I go to the back of the dryer and guess what? It is 155 degrees coming out of the back of that dryer. There is no vent hose crushed, so the airflow. I took the hose off the back of the dryer and had the customer run a load, and it still did not dry. And it's in a big room. It's not even in a little closet where it's restricting airflow. Airflow was great. There's no restrictions. So now what, guys? What do? I know the dryer's running. I know it's getting hot, and the airflow's not blocked. It's not restricted.
Possibly your thermostat isn't functioning correctly.
Well, if the thermostat wasn't functioning right, I wouldn't have the temperature, the 140, 160. It's either going to be too hot or less, or no heat at all if a thermostat's defective. There's something there in those last 4 lines that I wrote that is a hint. But this is the importance of the class for today. Drum turning. Now, when I say drum turning, in your head, you guys are saying, yeah, I open the door, I hit the door switch, I see it turning. What more do I do? Okay, well, guess what, guys? This drum runs at about 72 RPMs. So that means in 1 minute, that drum, hold on 1 second. 1 minute, that drum is got to rotate 72 times a minute. I'm sorry, I'm trying to copy an image and put an image in here real quick. I stole it from the internet, guys. But let's take a look at this now. This drum has to rotate approximately 72 revolutions per minute. Okay? Well, first of all, how are you going to count it? And why would 72 RPMs be important?
Give you an idea if there's a motor problem.
Not necessarily a motor problem, but the question I'm trying to ask is, why is 72 RPM, that number I threw out, why is that number important? What if it's 30 RPMs instead of 72? What would happen?
Maybe the clothes aren't.
The word's tumbling, Brian.
Yeah.
I hear you. So, in other words, if it's going too slow here, the clothes will go like halfway up and they'll just roll over each other and stay right here in this corner of the drum. And where the guy's hand is the filter. The back of the drum is where the hot air is coming in, and it's got to run across the drum. If the clothes aren't falling in the middle of the drum, the air won't flow through the clothes and remove the moisture. It'd be like taking your clothes and sticking it in an oven. They'll dry, but they ain't going to dry well because you don't have the airflow going through them. Now, the opposite is if the drum rotates faster than 72 revolutions per minute. What happens on a youth fair or those fairgrounds on some of them rides if they spin a little too fast? You stick to the outside wall. And what was happening with this dryer is if you took like a wet sock, it was running so fast as the clothes went up to the top, they're supposed to get to about the 1 or 2 o'clock position and fall back down to the bottom. And that's what these pieces right here are for. They're called baffles, but they're supposed to help push the clothes to fall down to the bottom of the basket or the drum. So if it goes too fast, the clothes stick to the outside and they never get the airflow through them. So what you do is you put a little black tape right here on this baffle, and you put a little black tape there, and you could do it in the opening of the door. You open up the door and you hit the door switch, but do this on the air cycle, not the heat cycle. And you count how many times the black tape on the baffle passes this in 1 minute. You set your stopwatch 1 minute, and you count. If it's 1 or 2 off, you're okay if you miss the count. But it turned out the manufacturer put the wrong size pulley on the motor. And it happened only in a certain amount of units produced. A 10-speed bike, you could shift the chain on the bike and it goes to bigger and smaller gears. Well, if you went to a smaller gear, your drum turns slower. If you went to a bigger gear, your drum turns faster. And what happened is the pulley on the motor was just a little bit too big, and I had to order a motor pulley and take the dryer apart and change the pulley on the motor. But the whole point of what I just said was not to teach you that the drum runs 72 RPMs, but the importance of this basic knowledge that a lot of you guys are here because you want to get better at fixing appliances. You want to be able to go into someone's house and figure out what the problem is. And reading a schematic and using a meter is not always the answer. This problem, a meter would have never helped me. None of those meters, the amp meter, watt meter, volt meter, whatever, none of them would have worked. So I have to know basic cycle, operation, and even installation. Now, I was always taught the length of the hose on the dryer should only be about 20 feet long with no more than 2 elbows or 2 90-degree turns, and this is a solid pipe. Well, if we look here, I have this open here. This is the customer's installation manual coming to the machine. A lot of you guys can get this online just through a Google search or something like that. And I'm not going to go through every page here. I just want to point out a couple of key things. We get the ventilation of the machine here, and first of all, they're showing you different ways or methods that this dryer can be vented and how it should be run, whether it's a straight run or it's offset through elbows, or very few do they come out the side, but you could vent it out the side. They even have these square boxes here to get you closer. Have any of you guys seen the recessed installations for dryers? One second.
Is that the one that's like inside of the sheet, like recessed inside of the sheetrock?
Yes, sir.
Yes.
Like these right here.
Yeah.
If you look at these or never seen these a customer can cut out the drywall in the back of the dryer, and they can push the dryer almost completely flush. So if they're in a closet and they can't push it far enough back and close the closet door because the hose in the back, so they crush in the hose. This allows them 3 or 4 inches, well, not 3 or 4, maybe about 2.5, whatever 2x4 is, that they can push the machine further back and connect the vent up. Right here, there's a hose right there if you can't see it, or right here. So the importance of this now is, look at this information right here. If we're talking a rigid or flexible metal hose, not like the accordion looking one, we're talking about the metal hose that flexes a little bit. Now they say you can go up to 64 feet, okay, but that's with no 90-degree elbows. If we add 1 elbow, we lost 10 feet. If we add 2, 3, 4 elbows, we've gone now to about 27 feet. Now that's important, because what if you go in someone's house and they're using the flexible hose, which you're not supposed to use, but they're using the flexible hose and it's got 10 twists and turns before it even goes out the back wall. Every turn of that airflow puts back pressure on the dryer fan and makes it harder for it to dry. But again, I'm not trying to teach you right now how to install a dryer. I'm trying to tell you guys, if you want to be a good technician, you can't just learn to read wiring diagrams and say, well, I got this. Because what if it's not an electrical problem? What if it's an installation problem? What if it's the manufacturer put the wrong pulley on the motor? You have to start to think, when you go in a house, yes, we approach everything as an electrical problem when we first get there. We go there, we turn it on, we want to see what's running, we want to see what's not running, and then we want to make our plan of attack on a machine. But you guys need to make a plan of attack on what you need to learn in order to do those things, in order to be able to troubleshoot these out. So you need to have all this knowledge of installation. So when I'm building these washer and dryer modules, I only put a sealed system class up there. There's going to be a separate one that's going to be refrigerator, where I'm going to talk about how the actual refrigerator works and the ice maker works. So eventually, I'm hoping by the end of this year, all of those appliances will be there, and for our paid members, they have free access to that. Now I've actually, the sealed system's up there, but it was in beta form. I've actually moved it over to another format called LMS. That'll be available to you guys also once I've finished uploading everything to that site. But everything will be uploaded to the TMM site as we go. So let's go back to this. So what knowledge do you need? You need to know the components of the machine. You need to know if it's installed properly. I could walk up to a machine and in 2 minutes tell you it's a mechanical, electrical, or whatever. So you have to be open-minded and don't always think every machine's an electrical problem. You could have a mechanical problem. What if one of the seals on the drum here, there's a seal on the drum where it meets this what we call bulkhead, and there's one back in there. Let me zoom in just a little bit. But right there, there's a seal. What if that seal's torn? Would that affect the dryer? And how would it affect the dryer? Anybody got any ideas?
It wouldn't dry properly.
Clothes will get caught up in it.
Okay, see, so you got a couple of things. Clothes will get caught up in it, and on Frigidaire, they have a front seal that goes on the bulkhead, and then the drum has a nylon ring, and some of the older ones didn't even have the ring, but that ring slides on this felt seal. And if the machine's 10 or 15 years old, the felt seal would wear down, and it would actually cause the front of the drum to sag. Hold on a second. And if the front of the drum sagged, what would happen is the bottom of the drum would actually get a larger gap. Okay, I think I got an image here. I'm sorry, I just want to show you guys this. I'm not going to play the video. I'm just going to fast forward to the point here. So if you see here on the Frigidaire, there's a felt seal right here, and the felt seal has some nylon glides on it. Let me see if I can zoom in a little bit more. You can barely see it. There's little white glides. This is for a drum that doesn't have the glides on the drum. They were here. So over time, these glides would wear out, and so now the drum's running on the felt seal there. But as the felt seal gets used, it gets thinner, and the bottom of the drum actually hangs down lower than the bulkhead. Clothes will get caught in there. And you know what? Customer's going to complain. They're going to complain the dryer is burning their clothes. Because what happens is an article of clothing get caught in there, and the drum will spin around the clothes and actually burn and leave dark marks on your clothes that look like burns, but it's not really burning. Now the other one, and I think, I don't know who said it, was talking about not drying, that this here is where the filter goes. And right here, this opening is the fan opening for the blower that circulates air. But if the drum is hanging down, instead of the fan just sucking air from the drum, it's going to suck air in here and not have proper airflow over the clothes. So you might not even think to look at that, but on Frigidaire and GE that use these felt seals, they wear down. The GE has the plastic ring here. I forgot what it's called. Drum Glide GE dryer. Okay, I found the Glide. Let me just see if I can find it on the machine here. Very similar to the Frigidaire. Let me see here. I'll bring this over here. Very similar to the Frigidaire. This is the nylon glides that the drum rides on. You can see this here. The guy's changing these glides. These glides wear out, And then the drum runs on the plastic, and I've actually seen it wear holes in the plastic. Here's a little bit better picture where the guy's changing the front glide. This is a GE dryer glide, and here you could see him installing it. There's no felt here. The felt is on the drum. And if that felt is torn or damaged, you're going to cause drying problems. So again, going back to the very beginning, all of these are not necessarily electrical, and you guys need to inventory yourself. Every single one of you come here with a different amount of knowledge. I don't know every single one. There's a few of you I know personally, but you have to inventory yourself. Say, am I good at understanding all the components in a dryer? And not just the electrical components, the mechanical components. Do I know the difference between a Frigidaire and a Whirlpool and a GE? How does the belt even go on the drum? You guys need to, I know it's hard for you to say, well, I don't know what questions to ask myself. And that's part of what I wanted to talk about today is you needed to know electrical understanding, but you also need to know the components in the machine. I know all of these components here in my head. I walk up to a dryer, I don't have to open it to know what the airflow looks like in this machine. I don't need to know that. Schematics. Yes, you need to learn schematics, but you also need to know mechanical things. So let's go to schematic for a second. This is a circuit for a light bulb. And I want to talk a little bit about schematics and troubleshooting now. A and B is considered what? What is that within the electrical circuit?
Voltage.
That's voltage, but it's also the plug. But it is the power source or power supply. What is this pitchfork looking symbol?
The ground.
Ground. And then this round part is what?
The load.
The load. Very good. I like that, using that word load. What am I lacking in this electrical circuit that almost every electrical component or appliance has?
A switch.
A switch, or we'd call it a control. Okay? I just realized who El Gordo was. I recognize the voice. Okay, control. So we don't have a switch here. The only way to turn that light on and off is by unplugging it, right? Okay, so let's go to the next diagram here. We got an open circuit and a closed circuit. What is open and what is closed? By looking at the two circuits, what's open and what's closed? The switch. But if the light bulb is broken, can the light bulb be called open or closed? Yes, it could be. We wouldn't necessarily say closed. We would say it has continuity or it has ohms. But if the light bulb broke, the little filament inside here broke, we'd say the bulb is open, right? So terminology is not that important, but understanding what that terminology is when someone's talking to you or you're talking to someone else is important. So let's just say this is a 120 volt light bulb circuit. If I put my meter lead here and here, what am I testing?
Hey.
The load.
I could be testing the load, but it depends on whether we're on voltage or we're on ohms, right? Because if I put my meter here and the meter's on ohms, I'm just checking between the two meter leads. I'm sorry that I tried to get it as a GIF, but I didn't have time to do it before class. All I got was the leads, otherwise so you can see the line. But if I'm doing ohms, I'm checking in between the meter leads. If I'm doing voltage, I'm not checking in between the meter leads. In this circuit, the voltage came down, but it stopped right here. The neutral came down and stopped right there. But on this one, the voltage came here and made it all the way to the light bulb, and the neutral came here and came this way. That's the difference. So let's switch now to voltage. I'm going to check voltage. I'm going to put the meter lead here and here. What's my voltage reading?
120.
120. So let's go back to this bulb here and this bulb here. What's my voltage reading?
0.
0. Okay, so now I'm going to flip it on you. What if I put my voltmeter here and here?
0.
I got 0 back. Let me hold on a second. I'm gonna see if I send these to the back. No, now it ain't gonna work. I'm sorry. I thought I could put it behind the. Okay, I have 0 volts, but why? Can you explain why it's 0 volts?
There's no difference in potential.
Very good. In plain English, for those who don't understand what you mean, is that both of them are line 1. Okay, that if I was to draw a line separating line 1 and neutral, it would be like this. So everything on this side is line 1, everything on this side is neutral. So when I put my meter lead on one side of the load and on the other side of the load, I'm going to have 120 volts as long as everything in my circuit is good. But if I move over to this one, because the switch is open, line 1 is not coming this far in, I have to find out why my bulb don't work. And the first test I make is, do I have voltage to my light bulb? It's the same for any part in an appliance. If you go to that dryer and the dryer's not running, we go back to the motor. The motor's what causes the dryer to run. And I can ohm it out, but I would rather do a voltage test and say, hey, do I have power to my motor? And if I have power to the motor, don't work, the motor's bad. If I don't, I have to find out why don't I have power, like this circuit here. When you check a load that's not working, you check voltage to it, you move the meter lead back, and I go to this point first, because if I have voltage here but I don't have it here, it's coming through the switch but it's not making it to the bulb, so the problem is a broken wire. But if the switch is open, no voltage, and then if I move here, now I have voltage. Finding the voltage, nothing here, and finding it here is allowing me to say, well, that switch is not allowing power to go to my bulb, and that's the problem in my circuit. I'm done troubleshooting. Now we went back here, we said, okay, if I go here and here on a circuit that's working, and I have 0 volts because they're both line 1, what do I have here across this switch?
On 20.
120 is correct, but why do we have 120? Line 1, and I'll do it in blue, line 1 comes in, but it stops here. And in yellow, I said in the circuit, when the load's working, the light bulb separates line and neutral. But when there is no current flowing through the circuit, the part inside the light bulb is a piece of metal just like the wire. So if neutral's connected to that bulb and the bulb's not running, neutral will do this and come all the way back up to the switch. And that's why we'd actually have a voltage reading. But I tell my students, I don't like checking voltage across a switch. It gets confusing, okay? Especially if you're on the wrong switch and you're checking voltage. But I would rather you guys, when you're troubleshooting, to do this and have 1 meter lead here and 1 meter lead here and backtrack this way through the circuit to find voltage. If I went all the way to A and I did not get a volt reading, You put the black meter lead back on the bulb, and you go back on the other side of the circuit finding voltage. That's what we do when we're troubleshooting. When we're doing a voltage test, we are testing not the bulb, we are checking the circuit, providing power to my bulb. Voltage checks out and away from my meter leads, where an ohms test would be checking in between my meter leads, like as if they were here and I was on ohms. I'm just checking this one part. If I'm checking the switch, I'm just checking this one part. So you have to understand a simple switch and a simple light bulb, a majority of you could check with no problems. But when you start to get to timers that have multiple switches, and you have parts that have like motors with multiple speeds and everything else, you have to know what two terminals on that part is that switch. So that is your understanding of the component. And you could read diagrams all day, practice diagrams at home all day, but if you don't actually have that machine in front of you to look at, I'm looking at a timer diagram on a dryer, but I want to look at that timer. Let me see something here. Give me 1 second, guys. I'm gonna let me just get a Whirlpool dryer diagram. I have Service Matters open. Give me 1 second here. Let me just see. No, of course, the first one I open is not one I'm looking for. One more second, guys. Alright, we'll take this one here. I'm gonna screenshot it and bring it in. Alright, here's a dryer diagram. Not a timer, but a board. Now, where do you begin? This dryer does not run. Let's take a look at this diagram. It's an electronic controlled Whirlpool dryer. You go up to the machine and machine don't work. On all machines that don't run, first test, and I'm gonna give you the answer to that one, is voltage in the wall. Do not take any screws off any machine until you determine you have the proper power. And a lot of people, when you see this horizontal line with the arrows, this is not a wire. It's just saying from here neutral to line 1 you're going to have 120, and from line 1 to line 2 you're going to have 240. That's the power coming in. But okay, you check the outlet. Line 1 to neutral is 120, line 2 to neutral is 120, and line 1 to line 2 is 240 volts. What is the very next step you do? I can't hear you, Douglas, you're muted. Well, let me ask you a question. Did I skip some steps by checking voltage? Tough question, right? Skipping steps when you're checking voltage. What about your communication with the customer? Trying to get an idea of how long has it had this problem? Is it always taking this long to dry? Did it just happen? Did you hear a noise? You know, your communication with the customer is your first line of diagnostics to try to get a better idea. You go to a doctor, you come into a doctor, hey doctor, I'm not feeling well, okay, lay down, and he starts cutting you open? He don't even ask you where it hurts? You know, that's the same thing as you as a technician going to a dryer. You're not going to start opening up panels until you get a better understanding from the customer what's wrong with the machine. Now you go there and the dryer don't run. You check power. You got 120 and 240 going into this machine. What is the very next step we do?
Check the motor.
Yeah, we could check the motor, but before we even check the motor, we are going to try every cycle possible, especially a mechanical machine. We want to check the time dry, the auto dry, the permanent press, because maybe the dryer works in cycle A but not cycle B. You know, you have to, like, troubleshooting is basically process of elimination. You all played concentration with cards. You took 52 cards, laid them face down, and you had to pick one up and find a matching one. If you didn't find it, you put them down, you pick it up until you run out of cards. And that's what you're doing on the appliances. One by one, you're saying, okay, what could the possibility be? Same thing with the game of cards. Where could that other card be? I'm going to try this. No, that didn't work. I'm going to try that. So in this case here, we got proper power. And Gordo, you said we're going to check the motor. How would we check the motor, and where would we check the motor?
The 4M and 5M.
Wow, that's a big job, because in order to get the 4M, 5M on that dryer, especially this Whirlpool dryer, these are one of the more high-end, you know, that go with the front load washers. Getting down to the that motor would take some time. Now, Stuart said on the board. So
Yeah.
could you be specific where on the board you would test? Let me make the diagram a little bit bigger for you guys. I see some of you trying to have a hard time.
Yeah.
Y'all,
Go P1.
okay. P1.
And you gotta find them. You gotta go back to the neutral. What is that?
Just follow the motor. Go through the motor.
Yeah. Go back to the P84.
P84.
Yes.
And what are you going to set your meter to?
Go to the 120 volts.
Yes. Remember, always start with voltage if you can. The only time we don't do voltage testing is where our safety or the safety of the machine or something, like back in the day we had the old Whirlpool dryers belt driven, and you wanted to check the solenoid on the transmission if it was getting power, but that piece moved back and forth and there was a belt running in front of you. You know, hey, that's not that safe. But if you were down there in the motor, you couldn't do that voltage test if the drum's there and everything. You could probably do it, but it'd be very, very difficult and unsafe. But if you checked voltage at P84 and P91, what must you do to check voltage there? What? Okay, we took our meter, and I'm just going to copy one of these and just use it as an example. I'm sorry, we're going to put the meter lead here. So we put the meter lead here on the board, and we put another one here. I'm not going to put the other one because it's going to block all the view. We check 120. What must we do? Turn the dryer on. Check a cycle. Now, if the meter says 0 volts, but the clock lights up, it looks like the timer's counting down. It went from 60 minutes to 59 minutes. Dryer's still not running.
It could be something else.
Well, we have 0 volts there. What do we do?
Backtrack.
Backtrack where? More specific. See, stop before you answer the question. Because part of the circuit you don't see, and there is part of the circuit you see. If I got the meter lead on door, is that motor really getting power from that terminal? Where I have my meter lead, is that motor actually getting power from that pin on the board? Oops.
No, because that's the neutral side.
Okay, but that's not what I'm saying. I'm saying is like this board. If I took this board out and put power to this board and only had the motor connected to these two pins, would that motor run? I took the motor out of the machine, the board out of the machine, plugged this motor to these two pins, would it run? Who said no?
Me.
You're correct. But why?
That door switch.
Because it's not feeding the neutral to the motor there. The neutral for the motor is coming from the door switch. You are correct. So what happens is, watch this. Let me get my marker here. So this was power going to the motor here. We tested here for neutral, but what if this door switch was bad? Neutral would get this far. Would I get 120 volt reading on my board at that point if that door switch was bad? No. Because if the door switch is bad, I will not get neutral. Will the board still light up?
Yeah.
Because of why? Why would the board
Because
still? Go ahead.
because power coming in.
Well, power's coming in, but if I said this door terminal goes to neutral through the door switch and this door switch is bad, then how would the board work? Through the neutral terminal right here. Look at this. See this terminal right here? That's neutral for the board. These two terminals here is how the board gets power. That's what causes the board to light up. It don't go through the door switch. If it went through the door switch, every time you open and close the door, the clock would shut off or the computer would shut down if it went through the door switch. But what's important about that terminal that I just pointed out to you, about this neutral terminal? You went P91 and P84 and you had 0 volts. Let's think about this for a second. So we said, well, if I have 0 volts, if the door switch was bad, that would make sense because my neutral would not be here and I would not get a reading. But I told you there's still something in this circuit that you do not see. What is it that we're missing that we need to get this motor to run?
L2.
Not L2. L2 is only for the heating element. L2 is here only for the element. The motor runs off of neutral and line 1. The board lights up. So we know neutral's good. We know line 1's good. We said the door switch could be bad if I don't have power on these two pins. But what is physically missing from this schematic that the machine has? You don't see it. But this goes back to the very beginning. You must know this machine. You must understand this machine. Because when I press start on the control board, what tells the motor to run? When I press start, I'm pressing start. What's telling the motor to start? The door switch?
No.
So what is telling the motor to run?
That's internal push the push button.
Not the push. There is no push button. Do you see a push button there? That's a mechanical.
Is it the belt switch?
It goes over from the start
There-
part.
But the belt switch. Okay, slow down for a second, guys. This thermal fuse, this belt switch, and motor, they could all be defective. I'll still have 120 here. Okay? So, I see the thermal fuse. I see the belt switch. I see the centrifugal switch. What you don't see is, how do I turn on the heater? What turns on the heater? A relay on the board. So what turns on the motor?
Kind of push button.
Yeah, but the push button is on the board. And there's a relay on the board that sends power to the motor. Do you see it in that diagram? No. So either this line 1 not only feeds a switch here for the relay on the heater, like when the board comes on, the switch closes. This can also go to the board to another relay here, or it can feed line 1 here, and there's another relay that's not drawn there. So if I don't have 120 on P84 and P91, my door switch could be bad, or a broken wire here. But there's a relay on the board, don't forget it. So we have 2 ways we have to go. I'm going to take this now and just go to a little drawing here. That here's the board. We got a relay on that board, and that relay goes to the thermal fuse, the belt switch, and your motor. Give me a second just to draw this. Here's your motor, okay? And then it goes up here to your door switch. Now we had an extra line here coming off of this, and this is where we checked 120. It said 0 volts. Well, either my neutral's bad, that's why I can't read it, or my line 1's bad, so I can go back either way. So going back to the schematic, I don't have voltage here and here. What meter lead do I move, and where do I move it? There's 2 ways you could go. Someone give me one way to make another test.
Or to neutral.
Motor to neutral. So I'm moving this P84 one, right? And I'm moving it down here. Let's say I got 120 volts there. What's wrong?
The door switch?
The door switch is bad. Can you ohm out the door switch from that board? Yes, if you go to door and neutral and unplug the machine, if you look, I go from here through the door switch right back to the board. I can ohm out the door switch from the board. I can open and close the door and see if the switch works. But what if I moved this meter lead from here to here, and I pressed start, and I still did not get a voltage reading?
And it's the board?
P91, I go over here to L1. I got 120 here, and I don't have it here. The board relay on the board's not sending power to it. So let's just say you determine that you have power at L1 and you don't have it here on P91. But you just don't feel that comfortable in ordering a board and coming back. You're like, man, I'm just not that comfortable about my diagnosis. What could you do before you leave to confirm, yeah, if I come back with the board, I'm going to fix my problem?
Maybe jump it.
Jump what to what?
P92 to P91.
P92, P91. Think about this for a second. 92 and 91 are right next to each other, right? P9 is the plug. They're both P9. And 1 and 2 is the first wire and the second wire in that plug. The first wire is going to be light blue, and the second wire is going to be black. And you can unplug that from the board and just jump it right there and make the dryer run. You don't even have to jump it on the board. You can unplug the plug and just connect that black and light blue wire with a little test cord and see the dryer runs. What if my door switch is bad? How do I jump that out to make sure that, okay, I tested, my door switch was open, but I still want to see this dryer run. I want to know the motor's good. I want to know everything's working, and I know if the customer sees it run and she knows I know what I'm doing. I think that the door switch is bad. How do I jump out and test the door switch?
And to neutral? T to W, right?
T to W, or let's be more specific, the actual plug and the wire on that plug.
Hold on, say that again.
Well, we said P9-1 and P9-2 because P9 is the plug and 1 and 2 is the first and second wire on that plug. So where on this board would I jump the door switch? You said TW, which is TW is what? The color of the wires. And that's tan and white. But if we said P91, P92, you tell me over the phone, I want you to jump this just to check it out.
P84, P83.
That's correct. You're going to run a jumper from here to here. So that's going to take this neutral and bypass the door switch and feed it to my motor. That way, I still have to press start on the dryer. If I jump out the relay 91, 92, I don't have to press start because I'm bypassing the relay, which is what says starts. But if I don't press start, this just kicked in my head real quick. If I jump this out, I don't have to press start because I'm sending power directly to my motor and it goes right out neutral. But what won't happen, I won't see this work if I just jump this and don't press start. The heater won't work. Why? Because if I don't press start, the relay for the heater won't come on. So if I just jump out P92 and P91, I will see the motor run. And if the motor's the problem, I'll know that. But I might confuse myself and jumping out and say, well, how come it's not heating now? Well, because I didn't press start on the dryer and didn't have the board close this relay on the board. A lot of times on these boards, believe it or not, this model I'm familiar with, the relay on the heater goes bad a lot. And when you look at the board, you got a couple of plugs with multi-pins on it, but the heater relay is just got two big old wires on there, one black and one red wire. So if I got a dryer running and not heating, I just jump out those two and see if I got heat. I do have to run the dryer. Why? Because look, the centrifugal switch in the motor won't close unless the motor's running. But in jumping it out, I can tell if the heater's working and know if I order the board, that's the only problem. I'm not going to come back and be embarrassed by changing the board and I still didn't fix the problem. Jumping things help only if you're not confident in what the meter's telling you. The importance of using a meter is like being in a dark closet without a flashlight. If you don't turn the flashlight on, you're bumping into walls to find your way out. The flashlight, you turn it on, you can see, and depending on how big the room is, you can only see where the flashlight is. That's what our meter is. And I have a lot of people put their meter and say, oh, I got voltage here and here, my board's good. Not really. Because I have voltage here. If I put my voltmeter on these two pins, basically all there is a switch here. And if we go back to this here, when the switch was open, we had a volt reading. So if you did voltage across this board here and this switch isn't closed, you'll get a volt reading, but you can see how that gets confusing. So going back to the importance of troubleshooting with voltage is we go one side of the load and the other side of the load. This is the line one side of the motor and this is the neutral side of the motor, and we only move one meter lead if we do not have voltage. We move this one back to find the voltage, or we're here on 9.1, we go back and find the voltage. If I don't have voltage here and I have voltage there, what's my problem? I don't have it on P92 here, but I do have voltage here. I kept moving my meter lead back, and that's where I found voltage. The wire. That's all I have between the 2 points. And when doing a voltage test, if the component's good, voltage will be on both sides of it. Like if you're doing a heating element on a dryer, and I say, oh, I have no voltage, I have no voltage. I have no voltage. I have voltage. I have voltage. If I have 1 or 240, and the other meter leads here, this I didn't move this one. I just kept moving this one here, here, and here. If I have 240 on this terminal and this terminal, that means power's coming in, and it made it this far. When I get to here and I have 0, it's because this black wire's broken and it's not giving power to that point. If I have voltage on both sides of that part, I could go to a Maytag dryer or one of them Samsung dryers. Those thermal cutoffs fail a lot. I'm sure you guys seen the element that lays sideways on the right hand side, and that thermal cutoff back there goes bad. Sometimes you can just change the whole heating element assembly with the thing. Let me see if I get a picture real quick. I got it right here, guys. So if we look here, and you look, here's the element, these two terminals right here. You can see it blown up. Okay, so if I put my meter lead here and here, and I don't have voltage, I got to find out why I don't have voltage. So let me just copy this, copy image, and paste it into the other program. I can put a meter lead here. Oops. Let me just bring my meter lead up because I want to show something. Okay, so you go to this dryer, right? And it's not heating. So you put 1 meter lead here and 1 meter lead on the bottom, and you don't have 240 to the element. Okay? So now you say, well, I could have a bad high limit thermostat, and I could have bad thermal cutoff. So I leave the 1 meter lead on the bottom one, and I'm up here on the top one, and I go here and I say, oh, I got 240. Oh, I got 240. I got 240. I got 240. But when I go here, I don't have 240. I don't have it here, but I have it right here. What's between those two tests? This blue wire. And that's my problem. If the thermostat was bad, I go here, no voltage. I'm leaving this one on the bottom one. I don't have them both here. No voltage here. No voltage. And then I go to the other side of the thermostat and I have voltage. It's coming in. It's not coming out. The problem's my thermostat. If it's my cutoff, the same thing. No voltage on the black wire. Go to the top one, I have voltage. My cutoff's bad. And that's how we find the problem. We keep going back till we find the voltage, and that's the way we can determine that. Now, I know this is a high limit thermostat because I said the high heat in the dryer was what? Go back just as a refresher. What was the temperatures that a high heat should be?
140, 160.
140 to 160. What's the temperature of this thermostat? Let me just rotate it around so you guys can see the numbers upright. What's the temperature of that thermostat?
260.
260. So why does it say 50 degrees? You see the 50, and it's got a degree symbol after with an F. 50 degrees Fahrenheit. Do any of you guys know what that information means on that thermostat? What's the L stand for?
Is that the limit is 260, but it should pop around 250?
You're close. The limit is 260, which means when the temperature gets to 260 degrees or higher, that thermostat will open. When that thermostat opens, what physically happens? If this opens up, what happens?
Cuts off the heating.
It cuts off the heater, so now your temperature's dropping. The minus 50 is when the thermostat will close back again. So if it opens at 260, when's it going to close?
210.
210, correct. So that's what this information is. This is the limit, 260, with a 50 degree cut in. This is what we call cutout. It opens up at this temperature, cut in, it closes at this minus 50, 260 minus 50, so it'd be 210. Okay? Guys, if you know the temperatures of a thermostat, You could be within 5 degrees. If you got a spare thermostat that's 145 on your truck and the customer's machine was 140, you good. You can put that one on there. Don't have to be manufacturer one. As long as it's within 10% of the temperature there, and it doesn't really go over 160, which is on the exhaust housing. Always on the heating element, it's a high limit thermostat, except for GE. GE puts some operating thermostats on their element, so it's the only one they're the oddball. But anyways, troubleshooting is important. Let's just recap real quick here before we leave. Is guys, it's up to you. If you guys want to get good at this, you can come to my classes. You can watch the videos I post all day. But if I'm not hitting on what it is you guys need, you're gonna lack. I need y'all's input. Send me an email and say, hey, can we talk about this in one of the classes? Can we talk about that? I really need help on this. I'll create even assignments where I'll email them out before the class, and then you guys can practice them, and then we'll go over them in the class. But again, every one of you have different levels of experience and understanding. Some people are really good electrical but don't really know gas. Some people are really good on mechanical but really don't understand the diagram or the meter. So, reach out to me, guys, so Brandon and I can come up with some, pertinent classes that's going to be important to you. Okay, so going here, it's up to you now to look at the notes that I wrote here and see what it is you feel competent in and some things you want us to go over and to help teach you guys so that we can create content. Other than that, that's it for today.